And good morning, all you wonderful people. And there is also a good morning from... Ta-da! Mitch is here. Okay, before we get into the actual meat of the thing we're going to do today, which is KiCAD/KiCAD, maybe I'll start calling it KCAD or something. I don't know. First, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, good morning. I hope we're coming in loud and clear. Yes, Mitchell. So I need to open that. Here we go. This is going to be the first time trying to use this. Use the hello-ometer.
System connected. Activating the super house.
Yes.
Squirrel.
Which means I can say good morning to Austin, David Howes, DIY in the Ghetto, and Henrik is here, coming in all the way from the other side of the world. Immy is here, Keith H. Hopefully Keith will be here in person soon for the barbecue. And so will Immy and Crispian. Luminator, Michael Wise is here. Mitchell is here, of course. Crispian is here. Russell, Scott, some call it fun. Steve the Squirrel claims to be here, but is only a cartoon, so I don't really believe it. Stephen George. Stephen, I hope you're coming along to the barbecue as well. It'd be cool to see you. Sion is here. John Whips. Kim S. Mechatronica. I don't know who Mechatronica is. Mike. Mike, you're here. I had a fun session with your brother yesterday. Maybe not as fun as the week before when it was just me and him. So essentially him beating me up. But yeah, yesterday was good. Oh yes, good. So Stephen says he's coming along. Oh right. Now, scrolling back through the chat. Scrolling back through, what is it, almost? No. Oh, okay, someone here is making a comment about your donuts, Mitch. Oh. Keith said, here, just got back from the local market and ready with a coffee and some fresh gluten-free donuts, almost as good as Mitch's. So, oh, Gavin, pity you can't make it. I think you've been to just about every single barbecue. I can't remember a barbecue that has happened without a Gavin here. So, oh well, I hope you have fun anyway. Scott, yes, you're here from yesterday. Okay, so today we might actually have the thing that I have been threatening for so long, which is me doing some KiCAD. But first, Rio Link, I am just going to give you a quick sneak view of inside the clean room. Let's get this up on the screen. Well, technically this is inside the clean room, but this is inside the pick and place machine inside the clean room, which is not what I was wanting to show you. What I was wanting to show you was this view. It doesn't look so good from the security camera, but anyway, you can see that there is now lighting all the way along this bench. The LED strip arrived, so I put LED strip under the first shelf running all the way along here. It actually looks quite dim. In this view from the camera, it looks dimmer than it does in real life. It's fairly well illuminated. Yeah, okay. Sion, you keep trying to put me off KiCAD. No, I'm going to call it KCAD. So what should I be calling it? Should I be calling it KiCAD or KiCAD? Mitch, what do you think?
Well, I asked JP Sharas, who was the original author of KiCAD several years ago, and he said...
_creations said, did you use the LEDPWM controller I sent?
No, sorry, Austin, I didn't even think of that. Sorry, go on, Mitch.
And JP said it's KiCAD, but he also said that he didn't mind how people said it, but that's how he says it.
Okay, Oh, Keith. Hang on, Keith, how are you not a mod? I don't know. Hang on, I'll see if I can do that. Alright, Keith, you should now be a mod. So let's do... I'm going to see if I can do this. Say... No, I can't remember the commands. Hang on, I'm going to make Keith's... Yes,
Keith
tell.
said KiCAD.
Alright, so the text-to-speech thinks it's KiCAD.
Imogen Ann said MoCAD.
Yeah, MooCAD. What have we got flying around in here? Okay. My friend wanted to know where you are, and I forgot myself. DIY asked, what's that about? I don't understand. Where...
Mitchell R said TomatoCAD.
wanted
It's
to...
Tomato Cat. I asked the author.
Tomato CAD. Where am I at? I'm in Bayswater. Bayswater, Melbourne, Victoria, Australia. Right, so, anyway. I'm just going to get out of that. And last night, I grabbed the most recent release, which is KiCAD 7.0.10, I believe. And there is a project in here that I had open ages ago in a previous version of KiCAD, which was the IoT access point, and this is the converted version. Let's see what happens if I open this. So this is the version that was taken from, the original one was done in Eagle, and then this was converted over to KiCAD. But we're not necessarily going to be doing that today, because I can't actually remember who did this. Was it you or was it Keith?
Not me.
I have a feeling it might have been Keith who did this, or was it... no, I really don't remember. Was it Gavin? Ah, Austin. It was Austin who did it. Nice.
Austin's_creations sent me.
Me. Okay, so Austin did this conversion of the IoT access point to KiCAD, but this is well beyond my KiCADing ability, which is approximately 0. So what we're going to do today is start with some of the basics, and Mitch is going to help me figure out how to drive KiCAD and do some some really basic things. And this is the first step in my journey to using KiCAD for real projects, and then eventually it should get to the point where I can work on complicated stuff like this.
John, it's fun way into KiCAD.
A fun way into KiCAD, yes, because what I'm going to do is tie several things together and use probably use a project from this as a starting point so that I can mess around with it and learn how to drive KiCAD. So what we could do is find a project. Doesn't really even matter which one, just one that's not too complicated. One of the things about many of these projects is that they have a lot of them have things like oddball inductors and stuff in them. This first one is okay, but there were a few parts, like if you look at this one for example, there were a few parts that were used on many of the Funway projects. There were like common parts that were in the designs. Most of these are pretty standard, but you'll often find things like little transformers like this, and some strange things that most people won't have lying around in their junk box. But some of them are just regular parts. So maybe we'll start with something really basic, maybe even project 1. And where are we? Here, this one, the flashing LED. So because I've been doing a bit of preliminary work on on recreating all of this content and rewriting it, one of the things I did not long ago, oh, Amanda is here as well, and Michael, thank you for coming along. So one of the things I did was I have been rewriting Dick Smith's Funway into Electronics Volume 2, which has been interesting because this explanation is wrong to how it works, which is kind of a big statement, but it really made me think about it. I know this is getting off topic of KiCAD. This is just kind of an intro to it, but so I've been in contact with Dick Smith, as in the person, not the company, a few times over the years about recreating or bringing back the Funway series of books. And the most recent discussion that I had with him, I basically said that what I would do is, to avoid any issue of copyright, I would rewrite the content, do basically the same so it'd be the same sorts of projects based on the same designs, but I would write it all out in my own words. And so I had to write the how it works section of this particular project, explaining how this circuit works. And it turns out that if you read this explanation and go through step by step, tracing what is happening with the sequence of the voltages on this circuit, it's wrong. What it's describing here is not actually what happens in the circuit. So yeah, that was interesting. I remember back when I can't remember how old I was when I had this book and I was building these circuits, but I can remember back then reading this explanation and trying to figure it out and being totally bamboozled. It made no sense to me, and I just ended up taking it on faith. I just cargo culted that this is the way the circuit worked, and built it, and it worked, so it must be all good. And it's only now, so many decades later, that I've come back and gone through this and gone, hang on, that actually does not make sense. So anyway,
I told myself one day I'd understand it.
yeah, it is a strange one. So it's actually not a good circuit to be showing people as their first project, because it's hard to explain. Even once you do, like, I now can't remember. I wrote this explanation out a little while ago. I'd have to go back and reread it to figure out again how this works. This circuit is like a magic trick. It's doing several things that are contradictory in order to make the LEDs flash. And so this is definitely not like a Hello World equivalent for a beginner. This is the sort of circuit that if you put this in front of an engineering student and said, explain this circuit, they would be scratching their heads over it. So, so don't feel bad, anyone that has puzzled over this in the past.
Maybe that it's all baffling here is just to get people used to the idea that there will always be things they don't understand, and they need to sacrifice chickens over, like RF.
Yes, that's true. Yeah, you'll graduate to becoming an RF engineer if you understand that that blinking LED circuit. Nevertheless, it is the first project in the book, and it's got basic parts. So what I'm wanting for my first attempt at doing a KiCAD schematic and then maybe even board layout from scratch is a simple circuit, simple in terms of only having basic parts. So it's just got a couple of transistors, a couple of capacitors, some resistors and an LED, and then connections for a battery, which could be just, solder points or whatever. It doesn't really matter what they are. There's nothing oddball about this. So it should be a reasonable entry point. So I don't know, what do you think, Mitch?
Is it worth switching to a 555 because you can explain that in terms of the rising and falling threshold voltage?
Potentially. There are some 555 circuits in the book, like this one. There's the electronic doorbell, and I kind of like the idea of doing a circuit that has no ICs in it, because I know that when and even though internally a 555 is relatively simple, if you look up the circuit diagram for a 555, there's not much in it. Conceptually, the way I looked at this when I was like 12 or whatever, I would always think of ICs as literal black boxes and unknowable. Even though, I suppose I think of that even more today. Like if I look at an IC that I use, it might be relatively small. Like say, even something quite basic like an H-bridge motor driver IC, I still see it as a black box. And you've got inputs and outputs and power rails, but how it does its thing internally, I kind of don't know.
Yeah, it's encapsulated functionality.
Yeah. So I do like the idea of doing one that is just basic parts to start with.
Let's do it.
Okay, let's do it. Are we still streaming? That's good. All right. Now,
Scott Miller said anyone serious about learning electronics needs to build a 555 from discrete components along the way.
yeah. Speaking of which, I'm chasing a squirrel after a squirrel here, but here we go. Smallest and biggest and smallest 555. Proof of life. This one, there was one, yeah, this one, I think. I've seen a few of these over the years. Different people have, so Johan asked, what's a 555? So a 555 is a very old integrated circuit which can be used to provide timing functions, and people call them different things like 555s, 555s. I've even heard people calling them triple nickels, which just sounds stupid to me. But anyway, it's a fairly cheap and very basic IC that you can use in timing circuits or to make oscillators, or so you can use it to do things like play tones or provide pulses, or so if you wanted to make a flashing LED, for example, where you're turning it on and off at a consistent rate, a 555 will help you do that.
So it essentially has two modes. One of the modes is where it'll produce a frequency which you can use to flash a LED or drive a speaker. You can also use it in a monostable mode, for example, where you push a button and it will stretch a pulse out for a certain amount of time.
Yeah, which is a one shot. So you might have something like a signal, like a button press or a sensor, which will provide an input which could be of indeterminate time. It might just be a little pulse, or it could be slightly longer. And you want an output that goes for a certain period of time, which could be, say for example, a classic example of this would be something like a timer on a light. So you want to be able to press a button in, say in a bathroom, it turns the light on, and then 10 minutes later it turns the light back off again. So its normal stable state is off, and then once it's been triggered, it goes into an on state for a determined time, and then it turns itself back off again, ready for the next time.
John, I was looking into this a couple of months ago, and I think 555 is the most produced IC ever.
That doesn't surprise me at all. Yeah, so this is a kit for the giant discrete 555 timer. And this has this is basically a build your own 555 using discrete parts. And you can see there aren't really all that many parts inside it. So it's only, I don't know, what, a dozen, 16 transistors and some various resistors and other things, a couple of diodes. So there's not a whole lot to it. Now, anyway, that one's that's a functional one. There are also somewhere, if I look for images, I've also seen, oh yeah, this one's cool. Oh, this is the same kit. That's the same kit, but with giant feet on it. Anyway.
Look, there's giant feet on it.
There's giant feet on there, yes. Yeah, so, enough of that. Let's do some KiCAD.
Squirrel.
Yes. Right, so what I'm going to do is just move that schematic out of view and alright, so now I'm in KiCAD. I'm just going to close that off, and so we've got this project here which I want to close off. How do I do that? Or don't I?
You won't need to.
I won't need to?
Yeah.
So is the idea that you have multiple projects listed in here and then you can just select which one you want to open?
No, so KiCAD stores things in different files. A project like an umbrella container will be the KiCAD profile, and then that will refer to a schematic and a PCB file. So typically they're stored in the same directory. So if you have a project called foo, that will be in a subdirectory called foo. Within the subdirectory foo, there will be a file called foo.KiCAD Pro, KiCAD SCH, KiCAD PCB.
Okay, great.
As Scott says, multiple projects, multiple windows.
Yep.
So you can have more than one open at the same time.
Excellent. That was one of the big limitations of Eagle, which isn't a limitation in Fusion, but that used to drive me crazy. I used to run multiple copies of Eagle simultaneously, just so that I could have multiple projects open.
Yeah.
So KiCAD takes care of that.
KiCAD sometimes will tell you if you have the project open in another window.
Okay.
Sometimes I've noticed it doesn't. I suspect if you just load the PCB file, it doesn't tell you if it's open in another window.
Okay. So what I'm going to do, I suppose, is create... the logical thing to do is just to make an empty folder somewhere.
That's a little... Like every CAD program has its own warts and complications and results of craft and stuff. One of the things with KiCAD is when you ask it to start a new project, it'll create the subdirectory for you.
Okay.
So if you're going to create the subdirectory, let KiCAD do that.
All right, cool. Well, then what I will do is make a meta folder, and I'll just call it Funway. And then what I can do is put the project directory inside that Funway directory and have KiCAD create that.
Yep.
All right, so under, do I go new project?
Yeah, it
or
might be
use
worth
a
just having a look
template?
at the template thing, but
Sure.
probably for us new projects.
All right.
So these are, if you were going to do, for example, an Arduino shield or something like that, there are templates for these because they're commonly done. So it's worth just kind of going through and having a bit of a look, but for most of my stuff I start from scratch.
Okay, that's pretty handy. So Raspberry Pi hat, a U hat, which is on the little smaller Raspberry Pis, Uno shield. Interesting. So yeah, it seems to be mostly oriented around add-on boards for existing board formats like Arduino and Raspberry Pi.
Yeah.
Arduino Nano. So there are system templates and user templates, which I don't have any yet, but presumably I could create or save a project as a template.
Yep. Useful within a company, for example, if you had a particular form factor, you had plug-in cards on a bus or something.
Okay, great. All right, so none of these are going to be directly relevant to what we're doing today because we're not building an add-on board that meets one of these standards. So instead of using a template, what I'll do is go new project.
Yep.
Okay, so create a new project and where I want to save it. So I'm going to call it, I'll call it Funway 2 1 because it's, I'll call it Funway 2 Project 1. All of this, I suppose. Is it hard to rename things later? Does it retain its references between files and things? Or?
Nothing a search and replace won't fix.
Okay, great. All right, so Funway 2 Project 1, I suppose we'll do for now, and I want to put it in, I will go back to, where are we? Where has it put us now? Into source. Oh, probably because that was the last place I was using. I had the IoT access point project in a source directory, so it's just used the same thing again. I'm just going to pull this off the screen for a second in case it reveals anything. I don't expect it will, but I'm just going into my Dropbox folder and Superhouse projects, and then I'll show it to you again. Alright, so I'm in Superhouse projects and I made a folder called Funway, so I'll go into that, and we've got a project called FW2 Project 1, and it's got an option for create a new folder for the project. Yes, we'll do that. And we've now got the PCB and the schematic file that have been created automatically. So I'm just going to have a look in the directory. So this is the directory on my computer, and if I go into that, it has created the PCB file, the project file, and the schematic file. Very nice.
They're text files, they could just be opened in an editor.
Yeah, great. Which is excellent for things like version control and diffing. Much better than dealing with binary formats.
Or even XML, which is ostensibly ASCII.
Mm.
Isn't
Yeah.
it? That's what Eagle uses.
Yes, that's right. Yeah. Which can be really useful because you can edit the files, or I suppose in some situations you can do things like automatic generation of templates. So I've seen people do fancy things like write scripts that will take a schematic and then generate PCB layouts from it automatically. For things like, I think I saw that for someone with a keyboard generator at some point. It laid out all of the keys on a grid.
Yeah, so KiCAD has Python scripting built in for PCBs. It doesn't yet have it for schematics, although there is a third-party library that will let you do scripting, but it's just not built into KiCAD. So the result of that is a schematic file.
Okay.
You can read in schematics, treat them as Python objects, do that kind of stuff, and then save it back out as a schematic.
Neat. All right, so we now have our PCB and our schematic. My guess is that the usual chain of events is to start with a schematic. So do I just open this?
Let's have a look at the things that are available, the icons there on the right.
Sure.
And then we'll have a look in preferences, I think, for a moment. So we've got the schematic and the symbol editor. So the way KiCAD does things, and this is different to Eagle, is that it separates schematic editing and symbols, which is what you put into a schematic. So a transistor in a schematic will be the familiar round circle with the bar in the middle, and it separates that from editing the PCB. So we've got the PCB editor there, and you'll have footprint files, and the footprint, for example, might be a TO32 3-leaded black plastic jigger, like in the Funway kit. So you might come back to here if you want to edit symbols or footprints when you're doing stuff. So generally you'll be going here for the schematic or the PCB editing. If you need to do symbols or footprints that aren't covered in the standard libraries, you'll be coming back to here.
Okay. Now this gets into a, for me personally, I think this is one of the most important parts of this whole process. Things like editing a schematic. It's a little bit like when you've been programming in one language and you start programming in a different language which is conceptually similar but it has different syntax. A lot of the concepts pass over. It's just a matter of learning different syntax and different optimizations. So I think learning how to use the schematic editor and the PCB editor are probably going
Scott
to
Miller
be...
said, does Mitch only have half a face?
He does.
I can get more on cam, but it means I'm whispering in John's ear.
Which is not a bad thing. So
the other thing to notice here, while we're here, I think it might be under preferences, is set up for symbol libraries and footprint libraries. So I've got manage symbol libraries, manage footprint libraries.
Yes, okay. So this is the big subject that I said to Mitch before the stream. I think this is conceptually the hurdle that I need to get across, which is how to manage libraries, parts, and all of those sorts of things, because I have so many years in my head of the paradigm of the way Eagle did it, and now the way Fusion does it. So I just need to get past that conceptual hurdle. And to me, the way I have come to think about it is that a part is a compound of the schematic, the footprint, the symbol, so the schematic symbol, the footprint that goes on the PCB, and the 3D object. And those things are all very tightly bound together. So when you are putting down a part in a schematic, you are committing to the physical the physical format of that particular part as well. And going along with that is the 3D representation of that. Whereas my understanding is that KiCAD makes those quite separate, so that you can put down a part in a schematic, and at that stage you are saying, for example, this is a resistor, but you are not committing to the fact that it's an 0603 resistor, or there could be a 5-watt wire wound or whatever. It doesn't matter. It is a symbol that represents a resistor, and how that is then implemented physically in the circuit is one level of abstraction away. Is my understanding of that correct?
That's it.
Okay.
And it also means that initially with the schematics, you're just worrying about the logical connections of things and the behaviour of it. And it's only later that you say, okay, what packages are we going to use for these particular things?
Mm-hmm. Okay, great. And so when we're looking at these options in here, we've got the footprint editor and the symbol editor as two distinct things. And then presumably at some point 3D will come into this as well, but we don't need to get into that now.
What I'd suggest is let's have a look at in preferences at the symbol libraries, because if you click on that, we'll bring that across. These are all the default ones, so there's a tab there for global libraries and one for project specific. Under global, they're all KiCAD libraries. These are the standard ones, and in terms of, okay, which library are we going to put which part, that'll be like if you've used KiCAD for a while, you'll get an idea of, these ones are all stuffed in this little thing. So that's something to get used to. So we've got a variable there, KiCAD 7 symbol dir.
Yes, I see that.
Yep. So generally in your project file, in your schematic or your your schematic file, it will make reference to KiCAD 7 symbol dir, so that if you take this to another machine where your system libraries are installed somewhere else, it'll still work.
Okay.
The other thing to note is that there's a library format tab there. So if we go to project specific libraries and you click on plus to add one, you can add, you might be able to add in one of your Eagle libraries.
Okay. That's assuming that I have one on the local computer now. I should have. Most of this, because I've switched over to Fusion, I think pretty much everything I have is cloud-based, but I think I've got exported local copies of some things just to mess around with.
As an awareness, we know it's there to come back to.
Yeah.
And it would be a matter of changing the KiCAD library format there to Eagle. I think it's a drop-down. Have a look.
Okay, just for the fun of it. Resistors. I'm just going to give it a nickname of that. Format. Oh, it's got KiCAD Legacy and Database.
Interesting. On mine, it's got a lot more, including I think Altium and Eagle. It might be a KiCAD 8 thing.
Could be. So just for reference, the KiCAD 8 is hours or days away from being released. The release candidate 2 has been out for a few days. And of course, because I always want the latest and shiniest thing, I was leaning towards installing the KiCAD 8. In fact, I did install a KiCAD 8 release candidate, but Mitch advised that I start with KiCAD 7 because this is the current stable release, and then when the 8 release comes out, I can use that. So we've got to migrate libraries here as well.
That might be for older KiCAD libraries. So I'm just looking at Sion in the chat.
Yeah. Ah, I see. Yes. So Sion said KiCAD 8 can import an Eagle library now, but that's not in 7. Yeah. 8 is still buggy, especially on a Mac, says Sion. Yeah. Okay, cool. So migrating from Eagle/Fusion is something that that's obviously a big deal for me, but not necessarily for other people. So what I think I'd like to do is try not to... I need to try to conceptually break myself from the Eagle way of doing things and see a clean start, essentially, so that I understand the mindset and the process of the way KiCAD works. And then if I do end up migrating things, at least then I understand the difference between the two systems. So rather than working by migrating libraries or anything like that, or existing projects, which I will need to do. So I've got hundreds of projects in Eagle and Fusion, and many of them I'm going to want to bring over into KiCAD to continue with them rather than continue with them in
Unexpected
the old
Maker
software.
said, honestly, I think you need to break away from the library way. Everything is embedded in the schematic or PCB, and you can easily build a library from that as you go. Also cleaner.
Cool. Thanks, Sion.
Yeah.
Yeah, exactly. So that's exactly the sort of thing I'm talking about, where I'm thinking about things the way I've done them for the last decade plus. So what I need to do is get into my head the KiCAD way of doing things rather than migrating things over. So
I think there's room for both.
yeah,
I'm just going to talk to Sion's point there
Go for it.
that footprints and symbols that you use are also embedded in the PCB and schematic file. So if that library became unavailable, you wouldn't be left with a schematic or PCB that wasn't valid anymore. So it's like they're cached there. So let's
Yep.
hop out of that. So it's
Okay.
really just an awareness that this is there to come back to.
Mm-hmm.
And it's a very similar dialogue for the the library configuration as well. Let's have a quick look at the symbol editor.
Symbol editor. Yep.
Again, this is we've got a list of standard libraries on the right there, on the left there, and it's familiarising yourself there. Device, for example, has a lot of useful stuff in it. So, device connector for things like headers and stuff.
Connector. Yep. Okay. So something like an 8P8C is a classic RJ45 connector, I guess.
Yep.
Yep.
So a lot of these con ones there will be useful for headers.
Yes, down here. So
Yep.
pin headers and sockets.
So if you double click on that, it'll come up on the right.
All right. I'm just going to pick one. All right. So that is the pin, and this is just the schematic symbol, obviously, because we're
That's
in the
right.
symbol editor. All right. So we've got 4 pins on this, and the cursor is snapping to the grid, which is cool.
Yeah. There's a grid you can set the picture that most people don't change it.
Yep. Yeah. On a schematic, it's highly inadvisable to change the grid because then you can end up with nets that look like they're connected but they are not, and things can go very badly wrong, at least in Eagle.
So there's an ERC that you can run that will tell you if you've got problems.
Yeah.
One of the things that it does is it looks at pin types and it says, for example, if you've got a net that's got all inputs and there's nothing driving it, it'll warn you about that. So that's one of the reasons why all the pins there have types.
Yep, so passive is the pin type in this case, I
Yep.
guess. Yep. So if I wanted to change that, how would I go about that?
There's 2 ways generally. You'll be pressing the E key a lot to edit stuff.
Cool. Yep. I see. Electrical type, passive, input, output, bidirectional, tri-state, etc. Okay, great.
The other way to do it is there's a little spreadsheety icon just below the window pull down, right up the top.
Oh, up there?
Yep, and that will do a mass edit of pins.
Okay.
Very useful if you're first putting in pins for a part.
Yes. All right. So
We'll hop out of this one.
Yep. So just close that.
Yep. A mini whistle stop look at the footprint editor, very, very similar.
All right. It keeps opening these windows on the other monitor by default. Okay. So similar sort of thing, if I went to the connector and I was looking for something like pin
I
headers.
think if you wanted headers, they're under...
Oh, connector. It's broken down into a whole many connector.
yeah, including
sections.
pin headers and pin sockets.
Yes, I see. So
for
in the
example,
different dimensions,
yeah.
2.54 millimeter pin header, 104 vertical. That would be. This would be one of the options to match up to that schematic symbol we were looking at a moment ago.
That's right.
Okay. So, are there any particular, if for example I put down a schematic symbol of a 4-pin header, similar to the one we were just looking at, is there any particular limitation on the footprint that I can associate with that? For example, does it just have to have 4
It just
pads?
matches on the number.
It's just on the number, so I could use anything.
That's right.
If I put down, for example, a 3-pin header schematic,
Yep.
I could put a transistor footprint down and
could.
it would match.
Yep.
Okay, so it's very flexible in that way.
In terms of somebody reading the schematic later,
Oh, that would be very confusing.
Yeah.
I'm not suggesting that's necessarily
Yes.
a good idea. I'm just trying to understand how this association
how
works.
coupled is it?
Yes,
It's really
that's
just
right.
based on mapping the numbers.
Mm.
There is something, I think, if you look at the symbol, they have numbers and names. So sometimes you want to give it a number and sometimes you want to give it a name, so they're
Yes.
separate.
Yes.
I've forgotten which one it actually maps onto.
Okay, cool.
I think
Yeah.
we'll see that. The other thing that's different from Eagle is the names of the layers on the right-hand side there. So we're talking about visibility. So we've got the copper layers.
Oh, yes. FCU for front copper, BCU for back copper. Yep.
Yep. We have adhesive for sticking your surface mount components on. Paste is the solder paste. I think that's called cream in Eagle.
Yes, it is.
You've got your silk screen, your solder mask layers. They're the most common ones.
Yep.
Of the ones you'll usually do, the other ones that are useful is the edge cuts layer, which
Okay.
is the outline of your PCB,
Yep.
and also the courtyard. So we're looking at this
Oh, yeah,
purple
which is-
rectangle there.
Which is equivalent to keep out in Eagle.
Yeah. Yep. So that says if this rectangle overlaps another rectangle, a similar rectangle for a component, it reckons you've put them together too closely.
Yes.
So they're the ones, for example, when you're defining a footprint here, they're the ones that you'll typically work on. Is the fab one there, which was the physical size of the component. So that's just below the courtyard.
Here, FFab. Oh, right, I see. So that's got a grey outline that
Yep.
just became visible, which is showing physically where the part is.
Yep. Then you'll put the silk screen down, which is the white on your circuit board that you want to show as a guide to people looking at it. Typically, it's a little bit larger, so you still see it when the component's inserted. And then there's the courtyard that says keep other things away. Sometimes the courtyard, for example, are pretty conservative. If you've got a SOT23 transistor and you want to squish them up against each other, then the courtyard is going to be a bit restrictive. So typically what you might do is take a symbol or a footprint from one of the system libraries and copy it into a project library and make specific to that project kind of mods. Or you could have a company library that you put modifications on the system symbols or footprints into.
Okay, this is really interesting because this is one of the areas that is a big limitation that has traditionally always been a limitation within Eagle and also within Fusion. And what I found myself doing over the years is that if I needed a customized version of a part, I would have to go all the way back to the library and duplicate the existing part and make a modified version of it. A classic example where you don't need to actually make any changes to the the pads, is you may want to put down a part without a silkscreen layer, but just for that particular part, such as a switch. So in my switches library, I have a part for a little 2-pin tactile button, and I've got the same version with the -NS variant, which is the no silk variant, because I duplicated it in the library, edited it to delete the silk screen, and then I have 2 parts that I maintain. So that's just one silly example. There are other things where you might want to change the diameter of the drill, for example, but just for one particular project. And because that is all very tightly coupled within Eagle, you can't edit at the final stage within the project and have the edits isolated to that project. So just from what I've seen, I think KiCAD gives you a lot more flexibility in that regard. Does it sound right?
Yep.
Yep.
So we looked at the preferences before for symbols and footprints, and per project you can add libraries there. You might, for example, have a superhouse one that here's my standard for superhouse when I have a particular tactile switch or something. You also
Unexpected Maker said, that is why I think starting from a clean library is better than bringing in a decade of crud.
True, but you have to know what you're doing when you start with that clean library. There's room for both.
Yeah. Yeah, and just, this is kind of a squirrel, but for me, one of the things that has been a big fear, and probably the single thing that has been the biggest barrier to jumping over to using KiCAD, has been the investment in libraries. So I have dozens of libraries that I've created, and they're all broken down into neat categories. So I've got a switches library, a resistors library, a capacitors library, etc. And then within each of those, I've got all of the different types of parts that I use. All of those are footprints that I've validated over the years. So I've used them on projects. I know they're good. I know that the paste layer is good, so they get the right amount of solder paste. And the idea of starting all of that from scratch is daunting. So I've been in this sort of transition paralysis state where I've been so deeply into that tool and that ecosystem that I'm locked in by that investment in library development. And the idea of beginning from scratch and having to create every single part from scratch is daunting. But there are these libraries that come with KiCAD, which should take care of the vast majority of things that I want to do. So I suppose the follow-on question from that is kind of about best practice for parts management or library management. Should I be taking the approach? Okay, so just to back up a little bit and explain where I'm coming from. With the libraries that I use in Fusion, I never put down a part on a board. Well, there are always exceptions, but my rule is I never put down a part on a board unless it's coming from one of my personal libraries. Now that part may have come originally from somewhere else. It might be one that I've imported from some other source. But once I put it into my library, I have checked all the dimensions and validated it, so I know that those are trusted sources. And third-party libraries might change with updates, because in Fusion they're all cloud managed, so you might get updates from someone else's library and that's now affected your own project. Whereas when it's in my own library, I know it's static and I'm the only person that's ever going to change it. So should I take a similar sort of approach, or does it seem reasonable to, certainly for basic parts like pin headers obviously, doesn't get much more basic than that, to
Except
use
as Scott
to-
says, the
exactly.
courtyards are pretty large.
Yeah. So yeah, the courtyards are very big in the default libraries. So I guess that I could do all of this 100% using the default KiCAD libraries. I could do it 100% using custom libraries or a blend of the two. So I'm just curious to know what's best practice or how much faith I should put in the existing content.
John, I feel that as you go on, you become comfortable with it, you'll be able to strike the right balance for you on which you want to go. Obviously, Sion has quite an opinion there on the way to go.
Mm-hmm.
I go the other way, but the point is that you can choose what's right for you.
Mm-hmm.
When Sion says it's better than bringing in a decade of CRUD, I see that as is better than bringing in a decade if I know it works.
Mm-hmm. Yes, that's right. It's a different way of looking at it.
So I think we might be starting to squirrel here. This is
Yeah,
really
yes.
just an awareness thing. We
Yes.
might be up to actually starting to look into the schematic editor.
Okay, sure. So I'll close off the footprint editor. So Sion just made the comment, I use both. I leverage KiCAD footprints for basic things, most passives, unless I need really tight footprints, and use my own custom ones, especially for DFM. Okay, cool. So DFM is designed for manufacture.
I'm with Scott too. I like Scott's comment there.
Scott's comment was, I keep a large collection of custom symbols and footprints on hand that I tend to prefer, but usually start with defaults and swap them in as needed. Yeah. Okay. So, because the, oops, I just clicked on schematic editor, because what I'm starting with here is going to be an extremely basic circuit. I'm pretty confident that, that the basic transistors, capacitors and resistors are going to be in there. So I could probably just use whatever is in the default libraries for this. Alright, what I just did was click on, oops, this is where things are going to take getting used to, like zooming and panning. So this
some of this is customizable.
Yeah. Yeah, so this is it. So folks, what you're seeing is me as a total beginner trying to get my head around this. And my general approach, if I am moving to a new software package, there are a couple of philosophical approaches you can take. One is I am going to tune this package to the way I like to work, and the other extreme is I am going to adjust my work to suit the package and the defaults of the package. And way back in the past, back in Unix, not Unix, in the days when Linux desktop environments were kind of crazy. There were things like Enlightenment and all the different types of window managers and rendering systems. You'd have people with different Linux desktops that would look radically different, and you could go up to a different Linux machine, could be running the same kernel and all of the same software, and it looks radically different, and you get lost. You don't know where you are. I used to dive deep down the fully customized rabbit hole and run an extremely customized Linux desktop with things like the behavior of window snapping and focus and all of those sorts of things being tuned to the way I wanted it to be. And I just found that it became a total pain, because anytime I changed machines, I would either have to customize the machine or I would have to change the way I think, and nothing would feel intuitive. So I've ended up sort of tipping over into the approach of try to leave things at defaults if you possibly can, which is also useful when it comes to doing things like getting support and looking up tutorials and finding information about how to do things, because generally they will assume that everything is defaults. So I could customize lots of key bindings and the way the UI works here, but I'm going to, and I may end up doing that, but my default position is going to be not to do that unless it's something that is becoming a barrier to me, and then I'll customize it. All right. So one of the things I have to get used to here is the way the in terms of input devices, the way I generally work is I have I'm on a Mac, so I have a trackpad under my left hand and I have a trackball under my right hand. I have no mouse. I haven't used a mouse for probably 15 years because of RSI problems. And so I've got very used to controlling, basically dual control of the cursor. So being able to do things like move the cursor with the right hand and pan the canvas with the left hand simultaneously, and doing zoom and pan on the left and pointing with the right. And the way that works in Eagle and Fusion is quite different to the way it works in KiCAD. So what I'm finding I'm doing is that I'm jumping around all over the place and zooming in and out and getting myself lost because it doesn't feel intuitive to me. But I've got to get a feel for how this works so that it starts to become natural, and then I'll be able to zoom in on the things that I want to and move around. So for example, my natural instinct is to use 2 fingers to pan, and that works going sideways in KiCAD. This is 2 finger dragging on a trackpad, but if I try to pan vertically, it zooms in and out because 2 fingers up and down is zoom, and pinch is also zoom. So this is pinching in and out to zoom in and out.
That might be customizable.
Yeah, that may be one of those things where because of my unusual input device choice, it is actually worth customizing, because doing things like zoom, I can do zoom with pinch, and I do not want 2 finger drag to also be
Scott
zoom.
Miller said may be able to fix that in preferences.
I think it's worth having a look.
Okay, let's have a look at this. So preferences,
So not this
Not
one.
there.
I think it's there. Yeah.
KiCAD settings. Okay, so
You've
let's
got
see.
another comment in the chat that might be.
Okay, so some caller fun said, if you drag vertically along the edge of the trackpad, does it move rather than zoom? Excellent question. No, I just tried dragging from, yeah, it works horizontally, but not vertically. So this is 2 finger panning horizontally, this is 2 finger panning vertically. So it's different behavior depending on whether you're moving vertically or horizontally.
There's a mouse and touchpad.
Mouse and touchpad, here we go. Automatically pan while moving object, interesting. So left button, middle button, so we've got, this is largely mouse related, which is not quite applicable to me, although the trackpad kind of pretends to be a mouse. So left button drag selected objects.
System notification, 1 hour remaining.
All right, so vertical touchpad or scroll movement. This is, I think, what we want.
Yep.
So we've got vertical set to zoom when there is no key selected, and then we've got Command Shift and Option modifiers. So I could do a pan up down or a pan left right depending on Command or Shift. But and it's got pan left right with horizontal movement always enabled. So I think what I want is pan up down on
Unexpected
vertical.
Maker said turn off center and warp.
Turn off center and warp. Turn off that one. Okay. So Command
Let's give it a go.
becomes pan left right. So zoom is still set to this. Should this be set to something else? Like set it to option just to...
If you're going to hold down one of those modifiers.
in order to make zoom happen. It just seems strange. Yeah, this has got a warning that there are 2 actions set to the same thing. So I'm going to assign that to option and do that. That's much better. So now I can, this is 2 finger panning and this is pinch to zoom. So that is now the behavior that is much more, this is basically the way Fusion works. So when you zoom, it centers on your cursor. It follows your cursor, which is great, and I can pan around. So what I can do is be zoomed in, and pan around whichever way I like. One thing that's kind of frustrating is that it only pans in one axis at a time, but I can get used to that. Okay. Oh yeah, Scott says while you're playing in settings, full screen crosshairs. Absolutely, this is something that I prefer.
There's an option on the right for that. Sorry, on the left.
On the left, where are we?
So this is mouse and
down here.
It might be under display options.
Yep. Come on. Grid style, dots will do. Full window crosshair, yes. And always show crosshairs. Yeah. So that has made, so we've now got the cursor in the middle, but we've also got crosshairs that go all the way across the screen, which is very useful when you're lining parts up and trying to keep everything consistent.
So if you're finding something frustrating, it's probably worth having a look in preferences for, there is likely to be a setting for it.
Yeah. Scott pointed out you'll want to do the same in PCB editor. Yes, good point. So at the moment we're in the schematic editor. The PCB editor will have its own settings, I guess. So that's schematic editor, and then if we go to PCB editor and display options, we've got basically the same fundamental options here in terms of crosshairs and grid and things, and different appearances on the right because it's different on the PCB. So if I go to here and go to, oh, it's got full window crosshair by default on PCB editor. So that's good. That may actually even be something that I changed in the past, because this is not the first time I've run KiCAD. I have used KiCAD in the past and looked at other people's projects. I've done very minor things with it. So somewhere in this computer there is a history of previous settings and things that some of which may have carried over. Okay, so we've now got a blank schematic sheet to work with, and
let's have a look at what we've got here. We've got some icons along the top. We'll cover those.
Yep.
We've got some icons along the left-hand side there, which is usually about kind of modes, for example, units, constraints.
Yep.
Turning
so
on
units,
and off a grid.
Sorry, millimeters. Yep. What is that one? Oh, full window. Oh, okay. So the option is right here. You can turn the crosshairs on and off in here. Don't even need to go into preferences. That one is toggle display of hidden pins. Okay. This is draw and drag at any angle. And constrain drawing and dragging to horizontal or vertical motions. I wonder if that... No, it doesn't make any difference to panning. It's just about drawing. So generally what you would want to do is keep nets all horizontal or vertical, and only in rare situations would you want one to go diagonally. And ironically, this very first project probably is one of those situations, but
Yes.
it is very rare. So normally we'd have it constrained to vertical and horizontal. And also, this one allows 45 degree. Okay, so toggle automatic annotation of new part symbols. Is that something I should leave on? I guess it is.
Yeah, default's good.
Yep, so that'll be setting annotation. So something like if I put down a resistor, it'll become R something.
R7, whereas if you got that off, it'll be R question mark, and you'll need to manually press the button that assigns them.
Got it. Okay, so it just auto increments the number. And show or hide schematic sheet hierarchy navigator.
Yeah, so you've got nested sheets. If you click that little off to the left-hand side will disappear.
Right. So this area on the left is the hierarchy of the sheets in the schematic.
Yep.
So in this particular case, for this very first one, we're probably not going to have hierarchical sheets because it's only got about 8 parts in it.
I use hierarchical sheets, and I usually have it turned off anyway, because you can do it with just clicking on sheets and then Alt backspace to hop out of a sheet.
Right. So it just saves it taking up some of your screen real estate.
That's it.
Okay, cool. Might as well leave that off for now.
Let's have a look on the right-hand side.
Okay. I think I'm going to bring this window across just to make it easier for people to see on screen. Okay, so we've got the regular cursor, so the select is the default behavior, and there are, oh okay, good, I was just going to say there are default keyboard shortcuts for selecting many of these different tools, I think. So in this particular case, add a symbol is A. So if I hit A, I will end up in the, I've just selected the add, and what you can't see is that it's giving me the option of selecting what symbol I want, but I'm going to...
It's intentionally doing it on a different window so that it doesn't obscure your schematic.
Yep. Yeah, which is very good. Okay, so
let's highlight
this one's highlight. Yep. Very good. Also, something that I would like to be able to do is bind many of these actions. So in this particular case, add a symbol, for example, all I have to do is press A on the keyboard to invoke this tool. Now I have a Stream Deck here which I use in...
Scott Miller said it is, in fact, possible to do it all without the mouse, if you're a masochist.
Right. Go for it, Scott. So what I do is, because I don't want to have to go to the menus to select tools, I have a Stream Deck which allows me to perform a whole lot of actions. And if, for example, I am routing a PCB and I'm running a track and I want to change layers, then there is a button I press on the Stream Deck and it sends a command to Fusion which changes layers, so it drops a via at that location and then proceeds on whatever layer I've selected. That's just one example. So I've got a whole lot of tools like that. And the way the Stream Deck works is that it sends keyboard input to the computer. So it's as if you've typed a command. The way Fusion does that is that it has a command line, and you can type quite complex commands into it with variables and different things. And then it'll parse the command line and process it. So what I want to be able to do, in this particular case, this is the add symbol. What I can do is have the add button on the Stream Deck simply send the letter A, and then it will bring up this tool, which is fine, that's easy. In this particular case, highlight wires and pins of a net. It looks like that does not currently have a keyboard shortcut bound to it. At least it's not indicating one in the tooltip.
Right. Yep.
So I assume that somewhere I can customize the keyboard assignments, or I could associate a shortcut with this particular tool. Now I just want to check. I did actually set up my Stream Deck for KiCAD like a year ago. I just want to see what happens if I press the plus button.
Oh no,
it worked.
Steve's bum's just fallen off.
So if I come up to my Stream Deck configuration, you can see that I had a profile already created for KiCAD, and it has detected that I'm in KiCAD, so therefore it switched to that profile. So if I go to Configure Stream Deck and then bring this up onto, I mean, this is definitely a squirrel.
Creations
I think we're getting a
KiCAD
bit...
has lots of shortcuts and does let you change many more.
Yeah, this is getting off the topic, but in this particular case, I've got this tool that just sends the letter A. But then what I want to do is bind show, for example, to that.
Yep.
So anyway, that's a future thing. All right, so we've got a bunch of tools here that in future I will bind to the Stream Deck. So add a power symbol, like a ground symbol or a supply symbol, a wire,
So
add a bus.
you'll be pressing A, P and W a lot.
A, P and W, cool. So A for add, P for power, and W for wire. Nicely phonetically associated. So no connection flag, wire into a bus junction.
I tend not to use these.
Yeah, it's the classic Pareto principle where you'll get 80% of the results with 20% of the tools. So then we've got was it net label, directive, global label, hierarchical sheet, add some text box, rectangle. Yep. Okay, cool. So all useful tools, but the basics are
Yep. Up the
parts
top.
and wires. Great.
You ready to go, John?
Yeah, okay. So
I usually start by hitting A and selecting some parts and just throwing them around on the canvas.
let's throw some parts around. What I should do, I should have some clue of what it is that I want to throw on first. But let's start with a transistor.
Is it worth putting the Funway schematic on the unused part of the screen there?
Yeah, let's do that. I'll bring this up here and try to position it in such a way that it's visible up there. And make it as big as will fit into that area. So right about there, and then once we bring this to the foreground, it should still be visible. Okay, so that's the Funway schematic up in the top right corner. Now, I can never remember this. I almost never use BJTs these days, so I don't even remember. Is a DS, is a DS,
BC.
it's a BC 548. Is
Yep.
that an NPN or a PNP?
It's a
And
NPN.
NPN. Okay. So it's got the arrow coming out of the emitter. So I guess I'll just look for transistors.
I would just type 548.
Oh, really? Okay. 548. And then in transistors, BC 548.
Yep.
Very nice. So my my immediate instinct was to look for, am I going to go SOC 23 or is this TO 92 or whatever? But no, I can ignore that. I can just put this down. Yeah.
You can set it if you want. A lot of the symbol files say here's a list of footprints, which we know works with this particular symbol.
Okay, cool. So I've just put down 1. In a situation where I want to put down 2 at this point.
1 is never enough, John.
1 is never enough. Can I just click again?
You
Or
can. And so you'll see the one that's used there.
Yep.
The other thing you can do, somebody might know this is a hotkey that says plonk down the last thing you selected.
Okay.
The other thing that I do is I just click on that part and then press Control D, which might be Option D.
So to click on that part, at the moment I've got the add, I'm still in the add tool, which means that no matter where I click, it's going to bring up this. So
it's a little bit like VI. If you press Escape,
yep,
it'll go back to
right. Then it's back
selection.
to selection mode. So I'm now in the selection tool, so I can click on it.
You can do copy and paste in the Mac way.
Yep. So I'm just going to try that. So Command C, move over here, Command V, and now we've got the part. But let's do
The other
it the
useful
KiCAD
one
way.
is Command D, which will duplicate.
Okay, so select it first, and then Command D, right. And select, move, drag. Other options I've got. Okay, I'm going to want to mirror the other one in just a moment, so I'll get back to that. But I just wanted to see what some of the things are here. Grid, zoom, select all. Oh yeah, duplicate is there. Okay.
System notification, 45 minutes remaining.
All right. So, how about I just do the Command D version and put it down here.
Yep.
Now in this particular case, I want to mirror this one. So if I go
So
right select,
the three options that you have, X, Y, and R.
Okay, that does make sense. So mirroring it horizontally is on the X-axis, mirror it on the Y-axis, or rotate. So without going to the menu, if I just have it selected and I just hit X, it has mirrored it in the X-axis. I like that. This is shockingly sensible.
Watch what happens to your cursor if you move it over the end of one of the pins.
Ah, right, yeah. It's turned into like a little wire and a plus. So does that mean that you can automatically just start putting a wire from there?
Yep.
Very nice. So no need to select a tool. It just goes into wire mode.
Yep. As Sion has suggested, there's a default which you can turn off where essentially just hovering over will do it.
Okay. So I'm just going to hover over this one and press D for duplicate.
Not
No,
D.
that was
Data sheet.
no.
So it'll be Option D.
Oh,
Is it
Option D.
Option or Command D?
Command D. That's right. Did that do anything? No, maybe I don't have the hover option selected. Alright, I'm just going to hover.
Hover over and press
do-
M for move.
Oh, X worked. Yeah. And then M for move. Yeah, okay, that is working.
Same for R for rotate. So you'll find yourself, when you've thrown all these parts on the board, you'll be doing a lot of hover, R and M.
Yep. Cool. Right. Very quickly, shortcuts are the way to do that. Okay, so Austin just said if you're doing it for a hobby, by all means spend time going through the menus, but if you want to design and work quickly, shortcuts are the way to do that. Yeah, so I'll need to start getting the shortcuts attached in my brain. But at least they do make sense. I really like the X and Y for mirroring.
Except I always mix them up.
Oh, right.
I always have to press it twice and then do the other one.
Yeah. Oh, Sion said Shift R rotates other direction. Right, so I can do R to rotate that way. Shift R to rotate. Shift R is rotating that way. R is rotating. No,
Squirrel.
it's not doing it on this one.
Squirrel.
Squirrel? Yeah, it is a squirrel. Okay.
We're going to run out of time, John.
Okay. Which is keeping me on track. Okay, so we now have 2 transistors. Hooray! All right, so now if I wanted to add some resistors, I'm just going to hit A for add and R for resistor. How about I do RES?
That's just got R. It's just
Just
called R.
Oh, it's just called R. Okay. Which hasn't narrowed it down a whole lot.
Yeah, it's down the bottom.
Okay.
Because it's sorted by library.
Oh, okay.
It's right down the bottom. Oh, yeah.
Video, close that up. Valve.
Redo the R
Track.
because it brought it up.
Okay, so I'll delete that and then I'll just do R. Oh, R, okay, so it is highlighted there. And then if I just press enter, it should select it. Yep. So let's just, oh, okay. This is slightly different behavior to Fusion. So I've just got to get the sequence right. This is in terms of putting multiple parts down. The way it works in
I think there's
Fusion,
a setting here. There's a setting where you can now plonk down
just keep clicking.
7 others here.
Yeah. So the way this works in Fusion, for those who haven't done it, is that I've just plonked down a part. If I now just clicked again, it would just keep adding the same part over and over again. So if you want to put down a few resistors, you just go click, 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 click. You don't have to do anything else. So in this particular case, I've just clicked somewhere else once. It's brought up the previous part that I used, hit OK, and then I can put it down. So I could do it this way, which gets me the 4. Or I could have done the duplicate or whatever. A few ways I could have done that.
I think
All
there's
right.
or
there's
some
a
other
setting
time
that'll
there's a setting, yeah.
allow it to be done. Alright, so now for basic editing, I want to move this part and I'm in select mode, but I can't just click this and drag it. So I need to go into move mode, don't I? So if I go over it and press M for move, I can now move it around.
Yep.
But is there a way that I, if I, oh yeah, okay, so you have to drag over it
There's
first.
2 forms of rubber banding.
Mm-hmm.
The first rubber banding is from left to right,
Mm-hmm.
and in order to be selected, a part has to be completely within the rubber band.
Yep.
This is quite useful for getting into corners and stuff.
Yes.
There's also from right to left, where it'll be selected if only part of it's in there.
Yep.
So right to left is more greedy than a left to right.
Yep. I hate to say this, but there was a new release of Fusion early in the week that changed all of the canvassing, and they've made it pretty freaking awesome. The way so they've changed the visual representation of the drag to select, and it shows a different color depending on whether you're doing like greedy select or just the non-greedy select. And it's yeah, it works incredibly well. And also I haven't had a single crash of Fusion since that update.
Nice.
But anyway, it's not stopping me from
Something else to
from
try
doing
while
this.
you're here.
Yeah,
Try selecting 3 of the resistors using the rubber band.
yeah.
You can use Shift and Select to add additional ones.
Shift and
So
select.
if you, for
said.
example, then rubber banded the transistor or clicked
Oh,
on-
right. To
Uh-huh.
yeah.
So the
to add
standard
that.
kind of schematic supply.
Yes.
I think you apply. You can also do a control and deselect particular ones.
Yeah, that brought up a menu when I clicked. But maybe.
Do it over the.
Oh yeah, I did. Shift Command.
So if you wanted to do all 4 except for one of them, you could rubber band all 4, and then you might have to be over the component.
Yeah. Well, interestingly, this is toggle. So this is the command key on Mac. At the moment, I've got the 3 resistors selected. If I hold down Command and drag across this transistor, it adds it. If I hold down Command and drag across it again, it removes it. So you can add or remove just by holding down Command and dragging across. Cool.
Great.
Right. Now, one thing that does annoy me slightly is that I can't just click and drag this. I have to select it before I can move it.
Just
But-
hover over. You don't have to click it, and then press M.
But then you got to press M to select it.
Yep.
Yeah, I can't just click it and drag it somewhere.
Yeah, I think most people would use it with the right hand on the mouse or the trackpad.
Yeah, and left on the keyboard.
The left on the keyboard.
Yeah. Okay. Yeah, and there's no visible anchor or origin point, but
There is in the symbol, but it's not shown.
it's just
on
not
screen.
shown on the display. Yeah.
If you're within the envelope or on a line,
Yeah.
it's pretty good at picking them up.
Yeah, so I don't have to be centered. I could be here, for example, press M, and then it selected it.
Yeah.
Or if I'm going to try being there, and it doesn't select it, but if I'm there and M, it didn't because it was on the end of the pin, but anywhere around here, it'll do it. Yeah.
The other
Nice.
thing is, and this is different to Eagle, is that you can independently. So the R there will be a value which you'll set eventually.
Yep.
So the R1, the R2 is the designator. The R below it is the value.
Yep.
So you can move each of these independently. There's no smash kind of thing. So
Right.
if you press M, if you're hovering over one of those,
Yep. Then you can move the designator.
yep.
Right.
There isn't a way to put it back to its default settings,
Mm-hmm.
but you could re-import that symbol there.
Yeah.
There's an option that would do that.
Okay. Yeah. So, for those who've used Eagle or Fusion, what Mitch is referring to there is the symbol consists of several parts. There is a symbol itself, there's a designator and the value, and in Eagle each one of those has its own origin, and they can either be all locked together, or you can use a command called smash, which basically breaks it up into its component parts so that you can then move the designator and the value, etc., independently of the part. And as you move them, it shows a rubber band telling you. So if I dropped this way over here and I thought, oh, what's that supposed to be associated with? All you have to do is hit M for move, and now it is pointing back to the part that it's associated with, so you don't lose track of it. That's really handy. Alright, so we've now got some resistors down. Okay, so I'm going to take a total guess. If I hit V for value, does that let me set values on these parts?
Yes.
Oh, fantastic. So V for value, and the value is currently just R, but what it should be is probably 330 ohms. Let's see. And V for value on that one, I'm going to set to 47k. That one, 47k. And that one will be 560 ohms. Alright, just copying off, I'm just taking the existing schematic as it stands. Alright, so let's put down A for add, and I'm going to just hit C for capacitor, and down the bottom here is selected it by default. So it's a non-polarized capacitor,
Yeah.
but in this particular case I want a polarized capacitor. So how would I go about finding that?
If you know KiCAD, it's C_pol.
Yep.
It might be if you type
Yep.
pol,
Which
you'll
is
get it.
actually by default the same in Eagle as well. So
Okay.
that makes perfect sense to me. That's what my symbols are called.
Great.
But if I just did out of curiosity, electro, I'm just going to look for electrolytic. It hasn't found anything because this is specific to, this is symbols, not the implementation of the symbol or the implementation of the part. So if I do C-pol like that, polarized capacitor, and then I've got a few options there, different symbols. I'm just going to go for the default one, C polarized. That's the symbol that makes sense to me. Now, before I put this down, if I wanted to rotate this, I guess I could just use the R key for rotate.
Absolutely.
Okay, so I still have it selected. I'm still in move mode, but the rotate key
When
has
you're in
been
move,
applied.
if you've gone move and you're moving it, you can rotate also as you move it.
Yeah. Okay.
So you don't have to separately rotate and move.
Yeah. Cool. All right, so I'll just plonk this one down approximately there. And if I do A again and enter, and then I'm going to do R, whoops. No, not sim, I pressed the wrong key then. I'm just going to go A, enter. Now this is, this is where my use of Dvorak keyboard really can come to bite me, because I can generally, if I'm typing words, I can type no problem at all. If you tell me to press a specific letter, I have problems. And what's on my keyboard is the standard QWERTY layout. It is not the Dvorak layout. So I can't even look at the keyboard to find the R. I have to put my hands on it and think, oh, R, it's there.
This might be where you need your Stream Deck.
Yeah, it could be. Okay, so I've got the two capacitors. I'm just going to do a V for value, well, V for value, and that one is going to be 2.2 microfarad. And okay, so in here we have a single value, which is the same as Fusion does it. And can you also have attributes? For example, what I could do here is put down 2.2 microfarad 16 volt
Yep.
as the value,
Yep.
but 16 volts is an attribute.
Yep.
So
That's what everyone does.
yeah, okay. So I should do it this way?
Attributes is coming in KiCAD 9.
Okay, nice. 9 or 8?
9.
9, okay, so it won't be in the 8 release. Okay, all right, so that's fine. And then on this one, I'll set the
System
value on that one.
notification, 30 minutes remaining.
Thank you, system. I'll make that one 10 microfarad, 16 volt.
The other thing is if you're...
Hang on.
That didn't save for some reason.
Oh, this one was still selected. It changed this one. Because even though I was over this
Yep.
and I hit V for value, it's editing the first one, not the one that was under the cursor.
So I guess the hover over only works if something else is
Yeah,
not selected.
if you don't have something selected.
The other thing is if you've got a certain value that you want repeated, it might be worth putting in the value first and then duplicating it.
Yes, that's right. So before copying the part.
The other thing is that the designator and the value is quite far from the actual component. You might not want to move those before doing the duplicate.
Yeah, so you don't have to do that alignment every single time. So in this particular case, if I was wanting to, up here the C2 is a long way from the actual capacitor, so I'll just move that to be directly above it, and
It's inland, it's a long way from the sea.
yeah. I just heard a double beep, which means I think Imi and Crispian have pulled up outside. Oh, okay, so Scott said you can hit enter instead of moving the mouse to OK. Yep, and you can also move on the grid with cursor keys. Interesting. So if I wanted to move this one, if I hit M for move, and now, yes, I can single step it across the grid using cursor keys.
It's very useful when you only want to move it on one axis and don't want to de-align something in the other.
Yep. All right. Now I'm going to slightly offset that, and I'm going to slightly offset that. Oops, not that much. In fact, I'll use the keyboard for that. No. Oh, when I hit escape, it undid, which makes sense. All right, so that, and then enter. Puts it down. All right, move, left, enter. Cool. All right, this seems intuitive enough. So then I'm just looking at this schematic over here. So we've got these particular pins all vertically aligned, so we're going to need a net along here. And I think what I'll do is start putting the nets in place, and then I'll probably need to move parts around just to get everything symmetrical, but at least I'll get a starting point. So if I do a W for wire, oh no, the wire, okay, this is interesting. So the wire started from the point where I had the cursor when I clicked W. So I can either come to here, I'm already in the wire tool, so if I click on that, I assume that'll be attached to that node now.
Yep.
And then if I click there, it terminates, and then click again and do that. So if I'm just hitting escape. So now I'm back in the select mode, and as Mitch showed earlier, it goes to wire mode automatically when you go over a pin. So all I have to do is click that, done. Click that, oops. Oh, okay, it's not going into wire mode there.
What I'd do here is,
yes.
I would either press W,
yep,
or I would rely on the fact that pin 1 on the transistor will put me into wire mode.
Yes. So once there has been a net attached to the pin, the little circle goes away. It's no longer an unconnected pin, so it doesn't automatically go into wire mode when you go over it. But if I click there and click there, it does. Okay, now one thing that I will probably do, just because I don't know, this is just an aesthetic thing, it's not a functional thing. You see here how this net is vertical and it is aligned off this pin. I generally don't bring pins into junctions.
Yep.
So what I would do, I've just moved over this, I'm just going to hit move and move to the right, and it has now deselected it and it's left the junction in place. So
move is dumb.
So move is dumb. So there are a couple of different rubber banding modes in this, aren't there? You can either move a part and it will dissociate from its existing connections, or you can move a part and have the connections retained.
Yep.
So
there's a smarter move,
yeah,
which is dragging.
Okay, so
and the key for that is G for drag.
Okay.
D was data sheet.
So move over that, and G for drag, and then move to the right, and now it's rubber banding and it's retaining a net. If I put it down there. Now one thing that I would like, this is a user interface thing, there is not a whole lot of contrast between the dark green that is used for nets and the dark brownish red that's used for pins, and they're the same width. So it's not particularly obvious where the net begins and the pin ends. Not that this is a problem, maybe it's just visual clutter, but what I'm accustomed to is a much more distinctive pin
transition
compared to net transition, exactly. But anyway, I'll just leave it as it is, I'm not going to change that. I'll see how I get used to it. So now reinforcing that, so if I go over this one and do G for drag and then left arrow a couple of times, hit enter.
Austin's_creations said themes can help with the visual.
Oh, okay. Cool, thanks Austin. Yeah, so one thing that I actually did a while ago in Eagle and then with Fusion is I turned on high contrast mode, and I found that really useful because what it allows you to do, you know, if I pick the highlight or the show or whatever it is here and I select this, you can see how that's gone like a purpley color. It's very distinct, and you can really see where that has
Outside the
been.
box said boo.
Crispian is outside the door. So you can really see
Scott
where
Miller
this
said
net
all.
is.
Preferences, settings, colors.
Yep, cool. So I was talking over Scott, so preferences, settings, colors. This I really like. Basically, this is what I wanted to achieve. The default colors in Fusion do not highlight this much. They just go from like a dark green to a slightly less dark green or whatever the equivalent is, and it's not that obvious. But highlighting like this, that's really good. So it makes it easy to pick out where that net goes on the schematic. So now what I'm going to do is hit the W. Nope, I've got to break that habit. I hit what I'm used to. This is a difference in the paradigm. With Fusion, you select the tool and then what you want to apply it to, rather than selecting the object and then selecting the tool to use on it. So what I'm used to is going into wire mode, just anywhere, and then clicking where I want the wire to start. What I need to do is be where I want the wire to start when I go into the tool. But for this particular case, I don't even need to do it. I can just click on the bottom here, come down.
In practice, I don't click wire all that often.
Yeah, because most of it is just going to be connecting unconnected pins.
Yep.
Yeah. All right, so now I can come to here and make these connections as they are. So, oh, I'm going to want to add an LED up there in a little while as well. Now this is going to be, all right, I'm going to do something that is probably wrong, but this is partly learning how this editor works. So what I'm going to do is put a wire in here and add it to there, and then I'm going to do the thing there. So what we've got here are these nets are the equivalent of these nets in the original schematic. But I'm going to want to put an LED in here and then bring these up. So later I'm going to want to move these nets.
Yep.
And my guess is that I can just go over it and hit M for move. But no, that is going to disconnect it. So what I can do is go over it and hit G for drag, and then it will move.
And
so
you could if you selected both of those with a rubber band before you start.
Let's
then it
do
will.
that. So I'm going to do Command Z and see if it undoes, which it does. So if I select those and then do G for drag, I can then just move them like that. Very good. Now
You could also select those three resistors and drag them up and down, and the wires will do the right thing.
right, so if I go G for drag, if I move them horizontally, it will attempt to retain the connections.
Yep.
And vertically, it'll just adjust symmetrically. Nice. All right, now I'm going to do W for wire, but I'm going to change this constraint over here. So I'm going to remove the constraint from vertical and horizontal to vertical, horizontal, and 45 degrees, except that I didn't want it to start right away. So I will click on here, come across to that point, and then I want to join it up to that net there. And likewise from here, I want to come across to that point and then join it up to that net there. So we've now recreated this little crossover, and normally I don't want 45 degrees to be allowed, so I'm going to go back to the normal constraints. So next thing I need to do is add in the LED. So I'm going to go A for add, and I'm going to totally guess and just do L for LED, and it's found an inductor, which of course makes sense. So I'm going to search for LED instead, and it has found an LED by default. So I'll select that. Okay, now this is interesting. I've got this floating part ready to put down, and using the keyboard shortcut, I can press R to rotate. This is back to its default. I'm going to right click and see what happens. Okay, so I've got a menu option. I can rotate, mirror, and do all of those sorts of things. Okay. What I'm just wondering is whether there is one of the buttons that will rotate it. but there's not. Okay, so I've got to rely on the keyboard to do that. Right, and I'll put it down there, and now I will just use the wire tool to do that, and then I'll select across that, G for drag, oops, move it down to about there. Alright, that can probably come, all of that can probably come down a little bit more, maybe to about there.
Nice.
Alright, now we've got a grid which is, I don't think you'll be able to see this on the stream because the dots are like literally 1 pixel or something on my screen, but I've got a dot-based grid that's just barely visible, and when I zoom in it disappears entirely. Is there, what sort of increment is this? If I just do G for drag on that, so that is directly intersecting the end of the pin. This is 1 grid notch up, and that's 2 grid notches up. Okay, so it's really just an aesthetic thing, but is there a particular sort of spacing that people like to use so that the schematic doesn't look too cramped? To me, something like 2 notches looks equivalent to a single, like 2 grid increments on this looks equivalent to a single grid increment on Fusion. So this sort of geometry of having the pin come out that far and then have the net come up here looks about right to me. It's got the right sort of balance of not being too cramped. Yeah, I could mess around with aesthetic stuff.
I reckon we should add a header or a battery symbol.
Yes, let's do that. All right, so I'll do A for add once again. Oops, got to put my hands in the right place in the keyboard. BAT has found battery, so let's select that, put this over here. What does it say on there? 3 to 12 volt battery. Okay. Right, and now I can, oops, no, I didn't want to do that. What I wanted to do was, I'm still in the add mode, so I've got to hit escape, and now I can add the nets.
Nice.
Yeah, so if I hover over this and do V for value, it just says battery, so what I can do is say 3 volts to 12 volt battery. That'll do.
Here's an example where typically, as far as a symbol goes, you might have the multi-cell battery there, but in terms of a footprint, you might have a header.
Yes, that's true, because there are 2 pins on this symbol, and what we would probably want to do is have a battery snap going off to a 9 volt battery with 2 wires that just get soldered onto solder terminals that are probably going to be on opposite sides of the PCB, not even near each other in this particular case, if we follow the arrangement of the original PCB. Ooh, running out of time.
System notification. 15 minutes remaining.
All right, so I just realized I haven't hit save at any point. I'm just going to do Command S. All right, saved. That it looks particularly lost and lost in the middle of the large schematic sheet. Okay, so we now have the schematic. Now, next thing I will do, I know that we're almost out of time, but I do want to have a very brief look at the PCB. Is this the sort of thing where we should do an ERC on this, or not now? Let's say not now.
It's one of those things where you may not want to see the result.
Okay.
But this is these are the kind of things that are on the buttons on the top. So
across
top
here.
right, typically. So let's have a bit of a review of those. Very useful. Is a little bit to the right. That one's an annotate. The a little bit to the left is an annotate, but it's all automatic these days.
Yep.
After that is the ERC.
Yep.
Then there's some simulation stuff, which we won't cover. Footprint assigning is quite useful. And then there's a mass edit one. So let's have a look at that one because that's very, very useful.
Okay.
So this, for example, would be a place to go and quickly play with values or footprints or...
Right. So conceptually this is equivalent to the design manager in Fusion, where it lists all of the parts and you can click on a part and it will jump you to its location and you can change its attributes and those sorts of things. So we can change values directly in here, I guess, just by editing this.
Yep.
So if I wanted, for example, to say that was a green LED, I could just change it in here, and it is changed on, well, once I hit OK, I guess it'll...
See how Q1 and Q2 have a drop down there?
Drop down,
If values aren't the same, it'll say mixed.
Right. So if I edited one of these...
To be a, say, 558.
Yep. So if I change that to be a 558...
you can also see that it's highlighting the symbol in the schematic.
Oh yes, down here. So you can see what it is that you're editing.
It'll also highlight it on the board.
Right. So I'm going to change that back to be the same, and it no longer says mixed values.
The checkboxes on the left there also say what it shows and also what it groups by. So if you...
right. So I could turn on different groupings. So if I turn off value, it no longer groups by value and it shows Q1 and Q2 as separate items. Or I can just group them together. Very nice.
This is often useful, for example, if you have a column that says what the source is, whether it's DigiKey or LCSC or something like that. You can group by the supplier and then have all the components for that supplier in one place.
Excellent. And it's got export as CSV as well, so we could use this for generating a bill of materials.
Yep. There's also add field there, so you might have a manufacturer's part number field or LCSC field, as many people have, or whether you have stock of something.
Okay.
So that's quite useful. We might, for example, want to, you can, for example, the transistors here, there's a pre-assigned footprint there.
Yes.
So TO92. That little bookshelf icon just to the right will let you go into and assign a footprint to that. So we could do that. There's also another tool that I'll show you in a moment that that is maybe a little bit more useful as far as assigning them goes.
Yeah.
So let's press OK and hop out of this one.
David Kaiser said run the ERC just to see what it shows. But is that something we should do, or leave that for another day?
Just for fun. But
okay. I'm just going to hit OK on that.
Yep.
So now it's updated the LED value, which was the only thing that I changed in that lot. So ERC is this one here, Perform Electrical Rules Check. Click on that, bring it over in here, make it bigger, and hit Run ERC. And it says violation 0, ignored tests 1, splice model issue. Okay, so it looks like we have no errors, which is nice.
Yep.
All right.
Yippee, your program compiled first time.
Haha, yes, ship it.
All right. So, if you want to spend more time on the circuit board, we could have a rough look today. I could come back next week. That's another option. Or we could do it out of the live stream.
Yeah.
But what I would do now is that little spreadsheet icon in the top right hand that we clicked on to do that mass edit there.
This one?
There's one just to the left of that, which is assign footprints.
Run footprint assignment tool. Okay. So now we have a new window, and it is listing the parts here highlighted in yellow that don't have any footprints, and the BC548s have had a footprint assigned to them by default. And filtered footprints. Okay, so if I select one of these, how do I now match it to a footprint? So just as an example, let's go for one of the resistors.
Yep.
Take the simple case.
Somebody might know this better than me, so jump in, anybody, if you know it. But what I would do is on the I'm happy to. I love this stuff.
Scott Miller said Mitch needs to plan on being present for a few weekends now. Ongoing KiCAD lessons.
Yes.
So the scroll bar on the left-hand side, we'll go through the footprint libraries. There's one for resistors in SMD and through-hole.
Okay, so we've got resistor SMD and resistor THT. And the footprints on the right-hand side are coming from whatever we have selected here. So I guess could I select multiples? No. Doesn't look like it, but if I've selected resistor through hole, I've now got a whole bunch of options on the right. And now, this is where experience with parts comes in, because you would start to know which ones you regularly use and what those footprints look like.
David Kaiser says the symbol's footprint filters settings help with the matching in this tool.
I agree. What do we click? I mean, I think we're in the right place now. The question is, which one?
Well, there's a little search up here. Could I use this for filtering? Possibly, but I don't know what I would filter on.
Let's pick one that's about 6 millimeters long and...
Yeah, okay, so L, I guess, is length. So it's got L, D, and P. So L, I'm going to go, there are a few here which are 6.3 millimeters by 2.5 millimeters. 2.5 for vertical, I want horizontal. So let's pick, on this one is pitch 10.1 millimeters. So there are a few different pitches. I want this to be quite relaxed, not a tight fit. So let's try for...
We can always come back and do this.
Yeah, we can always change this.
I think KiCAD 8 has a browser here.
Okay, cool. So it shows a representation of the footprint to you.
Yep.
All right, so I'm just going to pick horizontal through hole.
So you can double click here.
Yep, so if I just double click that.
If you keep double clicking, I don't know why the mouse jumped. This never made, I think you might be able to press enter or something and you'll get the same one that you got last time. Enter or space or something like that is useful where you want to give the same value to a bunch of things.
All right, I'm just going to try space. If I do enter, it's probably going to hit the OK and close this window, isn't it? So if I do space, it is just interesting. It's just toggling between those two. Okay, so if I select this one, oh, but it did highlight this. All right, so I want that applied to this. So I'll double click. Yeah, I've got to find it again. This is a bit of a UI quirk.
I reckon remembering the number might be helpful.
Yeah, number 20. Also, I'm just going to try multi-selecting here. So I'll select two of them and then assign the same footprint to both. So that works as well. Okay, so LED, I'll select that, and then on the left, I'm going to look for...
This is where LED, the filters, I think, might be helpful.
Filters. LED through hole, and let's go for a 5 millimeter. It's got a whole lot of horizontal. What does it mean by horizontal?
We want it sticking out the end like a remote control, I think.
Oh, right, okay.
System notification. 5 minutes remaining.
So if I just go for...
33 might be...
Number 33. Yeah, basic one, LED 5 millimeter. Let's assign that, and we'll see what that's like. Probably the most complicated one is going to be the battery, so let's ignore that one for now.
For bill of materials, you might actually want to have a battery and a battery snap and that kind of stuff. For what we're doing here, I would set it just to be a header.
Yes, okay. So for 2.2 microfarad 16 volt, I'll have a look in the capacitors section. So capacitor through hole, and we want axial. I'm just going to take a guess at somewhere around, well, it's going to be a fairly small one. Let's say 5 millimeter pitch, give or take. These ones are all large. It's 15 millimeter pitch. Oh, horizontal, okay. So I want the vertical section. This is better. All right, so capacitor radial 4 millimeter 1.5. Let's say somewhere around a 8 millimeter diameter, 5 millimeter pitch. It's going to be in that ballpark. It might be actually a bit smaller than that. We'll go for this one. That'll do. In fact, let's make them both the same. What number was that? It was 64. So we'll assign that one. All right, now the complicated one, the battery. So we probably want something like just the equivalent of a pin header. So
connector pin header.
Connector, is there a specific connector pin? And there is...
There's connector pin header there, if that helps.
Pin header with different pitches. So this one, for example, is 2.54 millimeter pitch. But in this case, what we want to do is put down two individual things on different ends of the PCB. So this is where I'm just going to bring up the original board layout for reference. It depends whether we want to follow the original board layout. So you can see here it's got the positive up this end, negative down this end, which is kind of unusual for a board layout, because normally if you had a connection to something like a battery, the two connections would be side by side, which is what makes sense. But in this case what they've done is followed, to some extent, the physical layout follows the schematic layout, with the positive coming in on this top rail, negative down here on the ground rail. So we could do it this way, or we could just put down a pin header with a pair of holes on it.
Well, I'm looking at the schematic here. The schematic has a kind of a brings them together in one spot. We'd just be following what the schematic does.
We would be. Okay. So what I would probably want to do is use something bigger than 2.54 millimeter. Is there anything bigger there?
I reckon we come back and change it later.
Yeah, okay. So I'll just make it a 2.54 millimeter, and it is going to be a 1x2. We've got vertical and horizontal variants there.
Yep.
I'm going to go for just a standard 1x2, 2.54 vertical. My guess is that's
Yep.
the most basic.
Yep. So if we now go into the mass edit, the little spreadsheety...
Did I think I hit OK without actually assigning it. Let's see. Yeah, I didn't actually assign it.
Okay, so here's an example where you
Alright,
can do it here too with a little bookshelf
So if I
icon.
click on this,
And here we get a browser, which is much better.
cool. So if I go to connector pin header 2.54, and then I had picked the vertical, this one.
Yep.
If I double click that,
Yes.
that'll assign it.
Yep.
And then we hit OK. So now we have parts, we have footprints associated with all of the parts. Okay.
So the easiest way to get this into a circuit board, so the traditional way would be to save this and then go back to the main window and go PCB edit. Or there's an icon up there that says push to PCB. It's actually not quite that.
Okay.
It might be the second right-hand one.
Now, this ties up quite neatly.
System notification, stream is over.
Yeah. Given that there are actually people here for the barbecue already, sorry, David said Command 0 to zoom all on screen, and I did that just after seeing that comment. So that is a really good tip. Thank you. So if I'm zoomed in here, for example, and I want to fit everything on screen, Command 0 takes us to that.
I think also try home.
Home, okay.
Yes.
I'm going to zoom in here and press home. Oh,
Didn't do anything.
no, it didn't
Maybe
do it.
it's a PC only thing.
Yeah, could be.
On a PC, home zooms out only enough that everything fits.
Right. Okay. So
what I usually do, just as a shortcut, is press F8.
which is...
It'll copy everything to the...
Alright, so I'm going to have to go into function key mode, because normally I have my function keys bound to other things. So if I'm going to press F8... Oh, you didn't see that because it happened on another screen. But now we've got people tooting their horns out there because I'm still streaming. Yeah, and what you can't see also is this. It opened a blank editor window, and it gave this with options for how it's going to convert all of those parts across. Changes to be applied, and then adding all of these footprints. Now, before we get into this, I think it actually makes sense to wrap this up now, because we've come to the end logically. I'm going to close that. The end logically of laying out the schematic, and that's a clear demarcation point. The next step is taking from the schematic and making the PCB. So maybe next week, maybe some coming week, if you're available, Mitch, we can do a part 2, which will be, let's take this and lay out a PCB. What do you think?
Good plan.
Okay, so is everybody else good with that plan? The thing is, I don't want to spend 5 minutes now just starting on the PCB and not actually get into it. So I think it makes sense to split that off into a whole self-contained thing. Okay, so yes, Michael says plan. Very good.
Thanks to all the KiCAD users who are watching today that had good advice. John, you've got them there as a resource. Obviously, there's people there who have a lot of experience with it. It's great to be able to help each other.
Yep. Oh, I have not spent a whole lot of time looking at the chat, but I'm just glancing back and I'm seeing, for example, Marty Smith just said, I find a hover over symbol on the schematic, then E or F, and if you click the footprint value, then you'll get a browser and you can see the footprint. So there are all sorts of things like that that I'm going to have to learn over time. Yes. So, thanks everybody for coming along. Oh, looks like a few other people. Oh, Dodgy is here as well. Marty Smith, David Crisp is here. Stephen W, Mad Monkey 71. Ecognito, Andrew Cochran. Who else turned up after I did the initial good mornings? Oh, Johan, Tassie Bob, and Reap Systems, David Kaiser. Yes, so thanks everybody for coming along. And also a huge thank you, everybody give virtual applause to Mitch for being my personal KiCAD tutor. It's, yeah, this is a very... it's a very relaxed way of learning it. It's so good having someone that can just direct me to the golden path rather than puzzling over what I should be searching for just to find out how to do things.
Oh, John, I just came for the squirrels.
Just for the squirrels. Oh, also, before we wrap up, one thing in relation to learning KiCAD, there is the Getting to Blinky video series, which is a few years old now, that Chris did. Chris from the AMP Hour, for those of you who listen to the AMP Hour podcast. So I haven't actually watched that series, and I don't think he's done an update on it in quite a while, which means that it may be a bit out of date. But Mitch, have you seen those or have any experience with?
I have. I think they were really good back in the day, the contextual electronic stuff.
Yep.
These days, I would point people to Phil's lab. He did a brilliant one-parter for KiCAD 6, and I think 2 weeks ago he released...
System notification. Peter is hangry. 5 minutes ago.
Yeah.
He released a two-parter for KiCAD 7 probably 2 weeks ago. So the first part is all about schematic stuff, the second part is PCB design, and because it's a comprehensive, he's laying out an STM32 board with Bluetooth. More or less everything that you need will be covered from the end-to-end process.
Okay.
That's what I'd watch.
All right. Great. Thank you very much, Mitch, and thanks everybody. I hope to see a few of you at the barbecue. I know there are people here already outside waiting, so I better get my skates on and start getting things organised. I hope you have a fantastic weekend, and I will talk to you all soon. Okay, thanks. Bye.